Hi guys, we are looking at 2018 3.6 Aqueous chemistry today. Like always, one question per video. Smash the like button if you find this video helpful and subscribe if you haven't. Okay, let's get into it. Question 1. So when sodium ethanoate is dissolved in water, the blah blah blah, just lots of blasts. Calculate the pH of 0.420 moles CH3COONA. So lots of blasts. You just need to be able to realize that CH3COONA, I mean, it's a base. This is a trick of how you can do it. So can you guys see the pKa value and the Ka value? And we gave you CH3COONA. CH3COONA it's just CH3COO minus, so the Na is a spectate ion. So if you get confused, and you can always write down the equilibrium for this to identify the acids and base, and that's what you get. So you should be able to see that the CH3CO minus is a conjugate base of the CH3COOH. Okay, so we're calculating the pH of a weak base. So this is a weak base pH calculation, and then you just need to remember the formula of H3O plus equals the square root of Ka times Kw divided by the concentration of the base. Just substitute numbers in. What is Ka? Is 1.74 times 10 to the power negative 5 times 1 times 10 to the power negative 14 divided by the concentration of base, which is right here, 0.420, and then if you crunch these numbers in your calculator, you should get 0.44 times 10 to the power negative 10. Don't think you're done here, because you calculated the concentration of H3O plus. pH equals negative log H3O plus, and then the pH will be the negative log of 6.44 times 10 to the power negative 10, which will give you 9.19, which seems right. Weak base 9.19 seems okay. Okay, so just be very careful. Memorize the equation obviously, but this is whenever they say pKa or Ka of something, whatever's inside the bracket must be the acid, and then if you look at this species here, that's obviously different, so that must be the conjugate base. That's how you can figure it out. Okay, so that's question number 1A. 1B, write the equation of the equilibrium occurring in a saturated solution of CaF2. So this is a sparingly soluble solid. What it means, if you dissolve it in water, you will get Ca2 plus and F minus, but this is 2F minus. And if you want to be a little bit more correct, I suppose, this is solid, this is aqueous, this is aqueous. The ions are always aqueous. Okay, calculate the solubility of CaF2 in water. Okay, so calculate the solubility. So this is a 1:2 ratio type of question. So this is where Ks equals 4x cubed. If it's a 1:1 ratio question, then Ks equals x squared. What is x? X equals solubility. Now what does that mean again? That means if I have x amount of CaF2 dissolving, I'll make x moles of Ca2 plus, I'll make 2x moles of F minus. Okay, in moles per liter. So just really easy. 4x cubed equals 3.20 times 10 to the power negative 11. X cubed equals whatever that number, the big number, divided by the 4. Then cube root the number. X will be 2.00 times 10 to the power negative 4 moles per liter. Please make sure you round to 3SF and have the correct units. Okay, next one. Part C, explain the effect of the following on the solubility of iron hydroxide. In water. Okay, so no calculations necessary. pH lowered below 4. Okay, so first of all, when they talk about solubility, I would strongly recommend you to write down the equilibrium, because once you write down the equilibrium, you can see a lot of information that you probably would miss. Okay, so this is the equilibrium. As the pH is lowered, so pH is lowered below 4. What does that mean? pH below 4, that means it's an acidic solution. It's becoming more acidic. What does that mean? What does it have? Which ion does it have when it's acidic? You have a lot of H3O plus concentration. So you have more H3O plus concentration. What does that mean? Well, the H3O plus doesn't do anything with Fe3 plus, but then you have the more H3O plus that can neutralize the OH minus. Okay, so the OH minus concentration from the system will be neutralized, will decrease due to neutralization. And so this OH minus concentration will go down. When the concentration goes down, then your system will no longer be in equilibrium because you don't have the balance anymore. So because this highlighted hydroxide concentration is decreasing, what does the system do to minimize the change? It will shift forward to make more OH minus. As a result of shifting forward, the amount of FeOH3 would decrease. The concentration will be lower, more of the FeOH3, the solubility would increase. Okay, solubility will increase, the equilibrium shifting to the right, and you have more FeOH3 dissolving. Okay, so solubility increases. That should be pretty straightforward, but the key thing is, guys, always write down the equilibrium first, and then you can think about, okay, what's the species here? H3O plus. It may look really irrelevant, but then as soon as you see the hydroxide and H3O plus, and then your year 12 Le Chatelier principle should come in and help you solve this question. So let's have a look at this part here. So ignore this. This is supposed to be equilibrium. So as the pH is lowered, you have more H3O plus. H3O plus will remove and neutralize hydroxide, and the results in the forward reaction being favored to minimize this change. Le Chatelier principle, causing more to dissolve. Okay, pretty straightforward, I do believe, but this is an excellence question. That's the thing with Aqueous. I think if you watch 1 year of exam of my Aqueous videos, hopefully you will understand the rest, because it's all the same thing. Okay, I don't get why this is a harder standard. It's technically, I personally find the easiest standard. All right, next one, potassium thiocyanate. So let's write the equilibrium again. So because we had it just now, and I just want it down here, so we can just go through the same process again. KSCN. So KSCN is made of K plus and SCN minus. So this is one of the complex ion formation. The K plus ions, this is a spectated ion, doesn't do anything. It has to be the SCN minus. And you should have learned, you know, the amount of chemistry you've done now should make you understand that the negative ions don't react with the negative ions. So something is supposed to happen with the SCN plus, SCN minus and Fe3 plus ions. And this year you will be given the complex ions formula. You won't be given the formation, so you will be given the complex ion formula of FeSCN2 plus. So you don't need to memorize it. This will be given to you, but you need to know how to make that. And this is where you simply copy paste Fe3 plus plus SCN minus, and then you produce a complex ion of iron thiocyanate, and the charge is 2 plus. Why is it 2 plus? Because you got 3 plus here, you got 1 minus here, of course combining together will be 2 plus. So what does this actually mean? So this is a complex ion that has formed. So the concentration of Fe3 plus, because the Fe3 plus, when they have the SCN minus coming around and they're like, hey, we can do this complex ion formation, so the concentration of Fe3 plus will decrease as a result of forming the complex ion. And when this concentration decreases, the reaction will shift forward to make more Fe3 plus to minimize the change. So as a resulting in shifting forward, the solubility of FeOH3 will dissolve more. Okay, more FeOH3 will dissolve, and therefore the solubility would increase. Okay, so this is a guaranteed excellence question. The moment you see complex ion, it's a guaranteed question, guaranteed excellence question. So just be very careful with the Cu2 plus, with the lead, with the zinc, with the silvers, with the copper, early done copper, with the iron 3 pluses. You know, these are tend to be your complex ion metals. Just be very careful with them. Whenever you see them hanging out with ammonia, with SCN, you know, alarm bell should be rang, and you should need to you need to check the resource sheet just to make sure you are confident that it is a complex ion question, and then you should be fine from there. Okay, so hopefully this is helpful enough. As you can see, very straightforward quick paper, I believe. So we'll move on to question 2 next. All right, and I'll see you guys next time. Bye bye.